Over at Sentek. We're going to go through a little bit about WiseCon, dive into drop control on that soil moisture monitoring platform. We're going to hear from Gil, and then we're going to go into a quick Q&A session at the end. So any questions or comments you may have, go ahead and just drop them in the Q&A box throughout the webinar, and we will get to them towards the end of the webinar. This will also be recorded and sent out to you when it is all done, and it will also be posted on YouTube and all of our social media platforms for you to refer to later. So first, diving into a little bit more about WiseCon and what we do. If you don't already know, WiseCon is a high-tech irrigation management company. We were founded in 2006. We've been in California since 2015 here in Fresno. We are a Chilean-based company. We serve over 300,000 acres with over 10,000 nodes deployed in the field. In California alone, we have 15 distributors, so we work with the dealer distributor system. We have 20 throughout the entire United States, but 15 just in the state of California. We have distributors all throughout California, Pacific Northwest, and in the Southeast United States. We have over 2,000 users in 5 countries, being Argentina, Chile, US, Peru, and Mexico. We have a fully staffed support team and warehouse here in Fresno in the United States, as well as in Chile. We have over 5 API integrators, meaning that we have an open API. We can connect with other companies to share data, to better serve growers, and exchange data, vice versa, as well as be able to plug into different sensors or programs as well and have them available on our WiseCon dashboard. So what is drop control? Drop control is a reliable irrigation management and control system. So we pride ourselves on being the forefront of the automation industry. That's what we specialize in. It's our bread and butter. However, we also have our hand in many other telemetry aspects as well. The first feature of the control system is going to be pump start and stop, as well as wireless valve control, opening and closing of valves, sequential valve operation per variety irrigation. We also focus on weather analysis through the use of weather stations, which you can see here. We distribute Davis weather stations, but we can also read data directly from the hardware, or we can utilize our API. If you have an existing weather station from Davis, we can just tie that directly into your WiseCon platform. We do a lot of soil moisture monitoring. So our focus today, we sell sentek probes, but we are sensor agnostic, meaning that we have an open protocol. If you have a sensor in the field that has an open protocol as well, we can retrieve data from that soil sensor. No need to replace it with a sentek probe. We can just read that data directly from that sensor onto drop control. And of course, we offer full remote capabilities. So what we pride ourselves on, our drop control app and our drop control desktop platform. So being able to schedule, turn on and off your pump, open and close valves, all from your device. So your iPad, desktop, cell phone, at home, in the office, out of town, whatever need be, you can analyze your soil moisture reports, your weather data, all from your device. We are comprised of hardware and software. Going into a little bit about our hardware and our 3 nodes, our X1 is our monitoring and control nodes. This is going to be our flagship node. It has full monitoring capabilities as well as control capabilities. So that full automation, opening and closing valves, on and off pump, and monitoring can all be done within the same X1 node there in the middle. Our M1 node is a soil monitoring node. So monitoring soil moisture probes, weather stations, dendrometers, etc. is going to go into an M1. It can operate as its own radio unit. Drop control uses 900 megahertz frequency that all nodes talk to each other on. That information then goes to the cloud. So essentially the M1 node can either be a cellular gateway in itself or a radio module to the gateway, which would be either the X1 or the C1 node. And going into the C1, this is our pump filter station control node. The C1 can stop and start 5 different pumps and 10 different valves all within the one. This can also be this also operates fertilizer pumps and acid injection through the C1 node as well. And as mentioned before, you can control and manage anything from your device or computer. So going into our software, you can schedule irrigations, you can do such on your device. It goes through Amazon Web Services to the WiseCon server, as you can see here. Then it all goes to the gateway, and then the commands get sent to the radio nodes in the field operating that procedure. This can also be done through a third-party platform. So mentioning our open API, if you have a third-party platform or company, our demands can be sent to their platform as well, and we execute it in the field. Talking about our desktop platform, our web page, which we're going to go into in a little bit here. This is what kind of our desktop web page dashboard would look like, and our mobile app available for iPhone or Android. This is going to be an overview map of your ranch. So when you get a drop control account, you can configure any amount of ranches that you have a drop control system on. We create this through a KMZ file on Google Earth, which we plug in the coordinates of your ranch into. So all those white circles are going to be every node or sensor located on each of your ranch. So we set those locations when we configure your ranch, and you can see the exact location. You can pin a Google pinpoint, so you can see the exact coordinates of each node. And tied into each of these nodes, when you hover over one of those white dots, which we can see when we go into drop control, it's going to tell you every single sensor that is tied into that node, as well as the kind of node that it is. And you can also see the status of the node, battery charging, the wireless signal, everything that is involved in that node you can see just on your platform. And as mentioned before, we specialize in automated irrigation, specifically in scheduling. So there are 3 ways to control how much or how long an irrigation will run. And that's going to be end date and time, volume, or the most common oftentimes is duration. So once you select your customized irrigation tactic, drop control will then calculate the water or the volume of water being put on, as well as the date and time. You can also schedule acid and fertilizer injections there at the bottom. Creating templates and programs. So this is useful when you want to run a set for, let's say, 2 weeks, 1 week, a month, whatever need be. This template is going to show us what's going to happen throughout the entire day for all 4 zones. While the program is setting that assigned template to take place for a specific amount of time, date, or weeks. If you want multiple irrigations to happen in one day for the same or different zones, you're able to do that as well. You can simply just duplicate the zone and set that start and end time or volume of water. As well as if you want scheduling to happen over the amount of 2 weeks or a month, you can just set the template to a program, and then you go into the program and set the amount of time you want it to run. As you can see there at the bottom, irrigation program. You can set the amount of days without irrigation. So if you want to run every 2 days, every 3 days, you can input the amount of days that irrigation is going to take off. And you can also implement a percentage modifier. So irrigating 10% more, 10% less, and so on. Using the irrigation scheduling tab, you can view your weekly schedule, your daily schedule all here. So as you can see, we have our irrigation program in those blue box up at the top for each zone. And then you have what actually happened there at the bottom in those green boxes below. These are green because there was fertigation applied to them. And your weekly view. So if you want to print this out or email it, you're able to do so. Just download it to an Excel sheet or a printable version, and you're able to show everyone in your operation what's going on for the entire week. On drop control, you're also able to view operational feedback, which is based on your sensors. The volume, flow, and duration are all calculated to show you what actually happened when you run your cursor over that lower darker blue bar on your graph chart. This is helpful being able to see if you are having pressure or flow issues as well. Manual operation in the field, so you can see your scheduler anytime you execute a manual operation or irrigation in that gold bar color. So not only are you able to see what you're scheduling or applying using drop control, you're also able to see what's manually happening out there in the field as well. Peak hour mode is an extremely helpful feature, especially getting into these warmer summer months with new peak hours implemented. That peachy orange color that you see running vertically down your graph chart for every zone, that's going to be your peak hour. This is always able to change in your settings on drop control. So with the new hours coming in, we've been changing the hours for growers. You can not only see if you're running into peak hour, but if you are scheduling an irrigation and your irrigation runs even 1 minute into peak hour, you're going to get an alert when you are able to set the scheduler, and it's going to say you are running into peak hour. Would you like to continue or cancel? So then you're able to go on and edit if you're unaware that you're going into peak. Here's a quick look at our app irrigation scheduling. So it's just as easy on the app as it is on the computer, and what your weather and soil monitoring would look like on the app as well. Getting into some flow meter readings, we're able to see the accumulated volume from a set time frame, such as throughout a season, as well as cross-referencing that with flow readings. In this example, we can see the weekly accumulated volume over that black bar and the flow meter readings in the red and green. This is using custom charts, which is another available feature on drop control. Pressure throughout a system. So on custom charts, you're also able to read pressures to 3 to 4 different pumps, whatever you're seeing. So right now we're seeing 3 different pumps over a 2-week span. If we were on drop control, we'd be able to hover our cursor over these tracks, the black, purple, and red, and be able to see the exact PSI for every minute of every day over those 2 weeks. Here we're going into our weather analysis tab on drop control, just a screenshot of that. Right now we're viewing temperature and relative humidity, as well as rainfall and ET directly below that. So you can kind of see the trends in temperature and humidity when there's rainfall, as well as ET cross-referencing that. Frost protection is another very useful feature on drop control. You're able to set your minimum temperature. So here we have 35 degrees when a frost event may happen in that horizontal blue line. And then we have our orange temperature showing us temperatures throughout the day over a course of time. And whenever our temperature drops below that minimum temperature of 35 degrees, when we may experience a frost event, you can set up to get an alert. You can also set an alarm, which would start your irrigation to avoid those chill events or those frost events. So this is another helpful feature on the weather dashboard. You're also able to set chill hours, so you can set multiple, and this was going to show us accumulated chill hours throughout a few months. And of course, soil monitoring is a tool we use greatly. So as mentioned before, we use sentek probes with sensors that reach depths anywhere from 4 to 6 inches, 4 to 60. These sensors collect soil moisture readings that are then shown on your drop control soil moisture analysis tab, which is what we're seeing here. You're also able to view moisture readings compared to irrigations that were ran, as well as rainfall and ET of the plant. So here we can see when the trees were drinking, which is when the soil moisture bar was lowering, and we can see that ET relative to that. We can also see at the bottom the dark blue and light blue bars, so the rainfall and irrigation, and showing the moisture raising when those events were happening. This chart here in the middle with the green, blue, and red is kind of showing our trend. So this is going to be added soil moisture. So it's adding all soil moisture from every single depth that we have selected on the top chart, and it's adding them to show us the trends of what was going on for every depth of that probe. This green is our fairway, which you're always able to set. This is obviously what we want to stay in. You can always set your maximum and minimum soil moistures on your drop control settings, all in your dashboard. And you're able to get alerts and alarms as well when you are reaching maximum soil moisture as well as minimum. So you can set an irrigation event to either stop or occur. And getting to ROI, so yield increase in this case was extremely significant. This is a testimonial featuring Tom Rogers. It's on our YouTube channel as well as other platforms. It's one of our many success stories and one of our larger ones as well. Tom lost a well in the beginning of summer, but he still saw a 5 to 10% increase in yield, as well as 30% water savings just from using drop control and being able to directly and precisely schedule his irrigation without that well that he had lost. And going into drop control on our desktop. So here we are viewing our drop control soil moisture analysis tab. So this is one of our demo sites out at Fresno State. Here on the left-hand side, under accounts, you can see soil moisture analysis. So it's one of our 5 tabs on the left-hand side. You can view your time selector, so we can set different times so you want to look at. We can view historically. So back to however many years you've had drop control, you're able to view that data. Select specific days, months, whatever you would like. You can select viewing 2 weeks, 1 week, up to 6 months. And here we can view our soil moisture chart. So we can see these vertical blue events are going to be irrigation. And then we can see our depths from 6 inches all the way down to 42 color coded up here at the top. If we want to only view our root zone, we can go ahead and just click these lower inches off to only view what we would like or what is relevant to us. You can drag and zoom to view more in depth based off that irrigation event. If we run our cursor over, we can see the exact date, time, and that soil moisture in inches. You can also have the ability to view soil moisture in percentages as well. And if we scroll down, we can see our fairway, so our added soil moisture for all of these depths here as well. And then relative to an irrigation event and ET. You have the ability to set your critical points. So here we have 2 set, and you're also able to change your maximum and minimum soil moisture. You can just reset your zoom. So right now we have it on adding all of our soil moistures, and then we have them in order of how much soil moisture is actually happening in inches. Or you can press the stack button, and it's going to stack our sensors in order. So anywhere from 6 inches to 26, it's going to be in order. So that is our soil moisture platform. It's very user-friendly. So all this information is coming from one specific soil moisture probe in one of our blocks out at Fresno State. But however many sensors you do have are all going to be listed under soil moisture analysis on your tab, so you can view each one individually. Alrighty, so now we are going to hear from Gil with Sentek, and he's going to jump into what they do over at Sentek and some really in-depth.
I'm going to start the kind of reviewing of how we come to these parameters from 2 schools of thought. One school of thought in regards to soil moisture monitoring is that you follow the probe dynamics to set your thresholds, or you can do an initial book value kind of quick math to determine what your thresholds are. The exercise I'm going to run through today is just looking at the book values where there's no interpretation. We're just going to be looking at hard numbers to set the thresholds. There is a fine tune that can happen after this initial threshold. Just to keep something in the back of our minds, remember soil texture, right, in regards to the sand, the clay, and the silt content is the driver for water holding capacity. So for anybody looking into depth into this, into these parameters, I highly recommend that you get a soil analysis with a particle size distribution. And then from those lab analysis, you're going to be able to start setting your thresholds in regards to field capacity, wilting point, and then what we look into maximum allowed depletion based on crop. So I'm just going to start here through my slides. So again, introduction to sentek probes. The core product we offer in this segment is the drill and drop. It's just a very reliable unit. It has a very high number of probes along the profile, and it lasts a long, long time. And then the value of moisture monitoring for farmers, consideration where to deploy these probes in the field, basics in reading the data, engaging with customers. This was a quick analysis that we had done for some companies up in Idaho, because they were kind of questioning sentek, asking in potatoes, which is kind of like off the crop here in California, but this was a quick number we ran for them. We found a publication that really went into the analysis of yield losses from mismanagement of irrigation. And the losses, we were really conservative. We were just looking at 30% losses throughout the state of Idaho, which was the case in this area. The state itself has an annual water stress risk in potatoes of close to $360 million. So when you think of farmers up and down the valley, many other parts like WiseCon is present in many citrus areas in Florida, I think that people have a very small vision on how much is at stake from the investment made in the technology. So just to open our eyes up on how much is left in these fields from mismanagement of irrigation. I'm just going to go really boring and reading these items here just to remember everybody the value of soil moisture monitoring. It brings up, when do you need to turn that irrigation on without causing plant stress? And plant stress, like I said, can be on both ends, either saturated or too dry. On this, we see a lot of saturated fields, actually more than we see dry fields. So a lot of farmers, maybe not this year that we have such a water stress, people are more aware, but a lot of fields are saturated when you look at some graphs. How long to run your irrigation without wasting water, energy, and fertilizer? Remember, every time you overwater and there's fertilizers in the root zone, the soluble nutrients will be leached out to the subsurface. And the rules are kind of changing that in regards to being more, how can I say, more aggressive in regards to really policing that. How urgent is irrigation needed in any given field? Determination of field capacity and the onset of stress. Like Sage showed in her presentation, that these can also be determined just by understanding the trends of water dynamics in the soil. What we're going to do today is book value, so it's a little different thought process. Prediction on timeline on when the next irrigation should happen, how to keep the fertilizers in the root zone, how much water to apply if you have a salt problem where you want to leach the salts. We had an instance in Salinas where we really had to keep on top of irrigation to keep the salts in the subsurface, because you also have the reverse capillarity action when water that has salt in it starts to dry out. As the water dries out from the surface of the soil, it will also bring the salts from the subsurface and crust up the top. So in Salinas, we've seen this quite a bit, where the salt is actually coming to the surface, and the farmer had to really keep onto irrigation to avoid those salts from rising from the subsurface. Root zone development, you can actually see where the plants are extracting water from, as you've seen that stepping pattern as water is extracted from the soil. Number of stress days, either from waterlogging or drought. You can count the numbers throughout a growing season. One interesting research here, it's probably a crop that not a lot of us interact with, but throughout the growing season, for example, 120-day corn, if you have 10% of those days, 12 days, that will cost you 50% of yield. So your window of opportunity in growing a crop is actually pretty small, right? Because once a plant's released abscisic acid, it takes over 2.5 weeks to recover that release of stress hormone once it has that really hard stomata closure. So that's something that really need to keep an eye on. Infiltration rates, to understand how deep are your irrigation events reaching. Drainage losses below the root zone. Soil salinity changes. One thing that we've seen a lot of farmers kind of not really pay attention to is salt index. Whenever you make a decision on any given fertilizer, you should be really interested in understanding what is the salt index of the fertilizer, so you're not adding more salt or choosing the fertilizer with the lowest salt index. So you're mitigating that year-on-year addition of salts to your crops. Soil temperature profile in other areas. This is critical to determine planting dates and also when to really start your field application of fertilizers. Irrigation and rainfall effectiveness. A lot of guys want to follow rain gauges and or ET, but the true weather station, which we actually have a pretty interesting slide where we basically flip a weather station upside down and put it into the ground, because you can really get rid of all your friction losses. You can really see that ET model, right? And if rainfall actually refilled your root zone. So these are just some parameters to keep in mind as we move forward. The company was founded in 1991 by Peter Buss. The technology we use is capacitance. Just a quick example of how capacitance works is converting a voltage into a frequency, and the travel of the frequency throughout the soil is how we determine volumetric water content as a percent, as there is a loss of frequency through the travel of the media when there's water, right? Water has a polar bond. It takes some of the frequency transmittivity because of the polar bond, and that's how we're able to determine volumetric water content in the soil through capacitance. And this is our workhorse that we call that sentek and Wisecon is very successful in our partnership in integrating the drill and drop into the drop control units. The drill and drop is basically a resin-filled probe, which is a multi-sensor profile probe that will have a sensor every 4 inches. A single point has 1 sensor. A 1-foot probe will have 3 sensors, 2 foot, 6 sensors, 3 foot, 9 sensors, a 4 foot, 12 sensors. We now have a 5-foot probe. It has 15 sensors, but it is not an undisturbed install. You still have to slurry it in because it's not tapered. All these probes here have what we call an undisturbed installation, where it's conical shaped like a carrot, where the auger has the same conical format, where you slide that probe into the soil without altering the adjacent soil water holding capacity. That is critical because when you install soil moisture probes with a slurry, there is a big change in water holding capacity adjacent to the sensors. So that's something that we really develop with accuracy, is the installation process with an undisturbed install. And then again, a single point, 1 foot, 2 foot, 3 foot, 4 foot. Now, one thing that we're going to kind of look into is how do we determine what probe do we need for any given crop? Here we have the probe is not called a drill and drop. It's called the slimline. It's a 5-foot probe or 60 inches. And like I said, it's a slurry install. And this is where we were actually doing some research in Australia on grapes. And we saw, because of this new technology and going deeper, a super improvement in grape quality by implementing regulated deficit irrigation at the correct time. And then here, like I mentioned, determining the probe length, right? This is a website I use as my guideline. I have some examples here of all the crops. One that everybody would probably be interested in seeing is what is the maximum root depth of almonds? So almonds can go down to 7 feet, right? So having a 5-foot probe or a 4-foot probe, something that would be very interesting to gauge irrigation management for almonds. And then we have a quick formula in regards to soil depletion. Now we're going to go into consideration of where to place the probe in a field, right? We always want to have the probe installed adjacent to the main trunk or root, a major tap root, right? Because we want to see the dry out pattern of where the probe is installed as water is uptaken by the crop. And here we have, again, the undisturbed installation. One thing that we want to be sure that you never want to install a probe right under the emitter, right? And you don't want to put the probe too close to the trunk. So you want to be about a foot away from any given tree trunk and about a foot away from the emitter. On smaller crops, that will vary slightly, but you want to be equidistant between the main taproot and the emitter. So you want to be right in between those two as you deploy these probes in the field. Just the basics of reading the data. Saturation, you have no air spaces. Field capacity is where you always want to be, where you have the balance of gravitational pull of water and the adherence between the soil particles. And wilting point is when the adherence is stronger from the soil particles and what the plants can extract. And then you never want to be there. And this is where I kind of want to show why soil texture is super important. In the similar water content for a sandy loam and a clay, you can have a permanent wilting point in a clay at 24%, and in the sandy loam, you're at field capacity. So understanding your soil texture, the most important factor to determine irrigation thresholds. And then we also have another tool that I'd like to share with you. The UC Davis has what we call the NRCS Surgo data, where you can overlay the soils map into Google Earth and then determine within a field what is your most representative soil type to place that probe in that majority of the representative soils you have. So it's kind of critical that you take a look at the soils map, even for irrigation designers. In Oregon, we've had growers basically cut out a 200-acre block to plant hazelnuts, and then half his field is in sand and half the field is in clay. He says this is a one irrigation set. Half the trees have died, the other half are okay. So when a lot of the irrigation designers should really take a look at soil texture as they're designing irrigation blocks, right? So that's something to keep in mind. And then I think I repeated this slide. Determining probe length, actually this is determining maximum allowed depletion. Again, I use the same link, the FAO website. And then again, using the example of almonds, we're gonna run through an exercise. So you'll never wanna deplete water holding capacity from a field with almonds less than 40% from field capacity. So you can only dry from field capacity 40%. And if the trees are recently planted up to 2 or 3 years, you even want to drop this to even lower to 0.3, right? In the Pacific Northwest, we've done trials with pears, and pears have really responded to half the maximum allowed depletion of a fully grown tree. So be aware, this number here of 40% is for fully mature trees. In between the planting time into a fully mature trees, consider half the maximum allowable depletion so that the plants in that really vegetative growth does not stress out. And then another free tool, I like free, but that is provided by the NRCS, which is basically you working from the back end to determine your thresholds. So from going back 2 screens, from the Surgo's website, you click in any given soil series and the map will give you what is your clay and your sand content from the map. You want to download this tool, which is called the soil water characteristics, and plug in the sand and the clay content in the soil texture triangle here, and they will automatically populate what is the approximate field capacity and what is the approximate wilting point. And we're going to go through the exercise of setting the thresholds now on what is full point, which is in the drop control, that the graph line between green and blue, and then green and red, which are the thresholds of critical on the top end and the bottom end. So we have field capacity at 30.5 based on these 2 parameters, the sand and the clay content. I'm going to subtract that minus my wilting point. That's my total available water. I'm going to multiply my total available water. I'm using the almond number, which is 0.4. I have a plant available water for almonds for this soil texture of 7.8%. And then I'm just going to subtract field capacity minus the plant available water, which is my onset of stress. So for example, in this field, I'd be turning the water on at 22.7% and then turning it off at 30.5, which is field capacity. There's no point in watering past field capacity per se, because then you'll just be leaching out your nutrients. Here again, just another example. It's field capacity, you turn the water off, and the onset of stress, you turn the water on. And then how do you convert that into inches? It's simple. The 4-foot probe has 48 inches. You multiply that by 0.3, which is the percentage for field capacity. So you have 14.64 as a full point inches. And then on the bottom end, you have 48 inches times 0.227, which is the onset of stress. And you have 10.89 inches for the refill point. And then when you subtract one from the other, you get the approximate irrigation inches between full point and the onset of stress. So for example, this field for fully grown almonds in this soil texture, you'd be wanting to apply 3.75 inches per irrigation cycles, as long as you're drying out all the way. So if anybody has any questions, we can go through this again. And then back into the software, how you set these thresholds, you basically have to multiply field capacity times the number of sensors, right? So actually this is on my farm. So I have a small farm, which the numbers are a little different. You multiply where is field capacity times the number of sensors. I only have a 2-foot probe because I bought the cheapest land, and at 2 feet here, you hit bedrock. So that's all you got, 2 foot. 2 feet, and then you multiply field capacity times the number of sensors, and that's your full point, and then the onset of stress times the number of sensors, and that's your refill point, which would be right there between the green and the red. Infiltration rate versus run times. So every soil texture will have a different hydraulic conductivity per se, and that will basically guide your run time, right? And I just ran a quick example here on when I approximately turned my water on. I turned it on about 8:30 p.m. this day, and then I watched it, given that WiseCon is very accurate in the upload of the data. I watched it. Whenever my deepest sensor started to respond, I don't have automation. I walked down to the pump and shut it off. So my run times currently for this soil type is about an hour 15. So I started at 8:30 p.m. and at about 9:45, I had the last sensor starting to respond. So that's all I need based on run times to not leach out past the root zone that I have for the small trees I have. And then we're going to go into what VIC means, right? VIC stands for volumetric ion content. A quick schematics on what volumetric ion content works. It's the same technology as soil moisture monitoring, except that we have 2 frequencies. One frequency takes into account the water curve, and the second frequency takes into account the ions. Remember, we'll have more of a friction loss when you have 2 frequencies. When you have more ions in the soil solution, you lose more frequency transmittivity when you have ions in the soil solution, which is the opposite of other measurements. So I think ours is very accurate because we'd only be measuring the ions that are in the soil solution, never have any influence by salinity or even soil charge. Remember, soils are negatively charged by nature, and that influences conductivity. So if you're really looking for accurate fertilizer management, the VIC in our sensors has the highest accuracy because we're only measuring the ions in the soil solution without any other interference from soil charges. Just reviewing our certified crop advisor numbers and how nutrients are uptaken by crops. So for example, nitrogen, 99% of nitrogen is uptaken by mass flow. And that's why it's critical in the vegetative growth where you're applying nitrogen to have your crops as close to field capacity as possible, because then you would have the maximum yield because nitrogen is uptaken through mass flow. We can also see that sulfur is very dependent on water, and then calcium, right? Once you see calcium deficiency in a crop, it's already too late. It's really hard to correct that because it's a structural element. It's also immobile. So for example, if you mismanage irrigation in apples, in pears, and other crops, tomatoes, there's no correction for calcium deficiency pretty much. And that's why irrigation management is critical at those growth stages. And just reviewing in regards to profile depth extraction by root zone. So 40% of water extraction happens in the top quarter of a total root zone. 30% on the top half, and then a lot less as you go further down, because there is a hydraulic limitation from any given crop. And then here, I didn't have a good example from the drop control unit, but here we have an example from sentek in regards to how to implement the VIC as a tool. You install the VIC, don't focus on what the numbers are, because a lot of people are really looking into decisiemens as their salinity gauge, but we are working on a filter to convert VIC into decisiemens. But what we're looking for here is to get the native baseline in the very beginning of the season. So if you have a probe installed early January, the probe sat there all winter in the ground, you have your native background on VIC. This is native. It's been in the ground for a long time. You apply your first side dress with 50 pounds of nitrogen. You let the plants use up that nutrient. And then, you know, am I done with my vegetative growth, or should I side dress? Remember, a lot of the nutrient uptake is based on growing degree days for many crops. And then you can see that you're not doing it without guidance. A lot of guys says, oh, I'm going to side dress on a calendar date. But if it was a cooler year, for example, maybe you haven't used all the nutrients. So really following the VIC, the key to success. And then here, just we all have all these new headwinds in regards to things farmers need to manage and how we make their lives simpler. And if anybody needs to reach me, this is my contact information. Are we still there?
Yes, you're still here. You might need to
Excellent.
let me read you as a host.
Sure. Yep.
All right. So now we can take some time to answer any questions you guys have for Gil or for myself. Feel free to just drop them in the Q&A box.
I don't think anybody has any questions.
I know.
Now we can give them.
Good job.
Now we can give them the actual exam.
Yeah, right. There's a test.
Exactly. If anybody wanted to look at this information, there's really good information at Cornell's Certified Crop Advisor website. That's how I passed my exam. So if anybody want to check Cornell's website, there's a really good exam in there.
All right. Well, we'll hang out maybe for another minute or so and see if you guys have any questions in the Q&A. Otherwise, Gil's information is in the chat and I'm putting mine in right now. Feel free to email or call us with any questions you have. This webinar was recorded, so it'll be emailed to you when it's posted on the YouTube page and social media sites.
Yeah, pretty interesting, Sage. You guys have such a robust platform, and we do that one little part of the soil moisture probes.
Yes, well, the information is greatly needed, so thank you very much for that. Yeah, I think soil moisture is probably one of the larger things our users definitely pay attention to on drop control. Definitely, it's very helpful.
Yeah. Yeah, when I'm not sure if you guys have seen the latest futures index from the VELS. I think that's recent from this year. The last I looked, an acre foot of water was $870 past the delta.
Wow.
So if any gonna, yeah, it's not cheap. And now when you got the banks, when you got the banks going as a speculative market on water,
Yikes.
It's gonna be a new roller coaster.
Yeah, we're getting into some crazy times here. So people are going to need to be monitoring what they're doing.
Maybe we need to ask people some questions.
What was that?
No, maybe we should ask some of the panelists that are here a question, if they have any questions of their crops or anything.
Anyone have any questions? Yeah, anything particular about your operation? Still have some people.
We can run the exercise that was on, yeah, maybe like you said, when you send the slides to the group, they can run the quick example on their soil texture for their crops.
Yeah. We have one, was there a post-training quiz you did today? No quiz, but like Gil said, we can send you the exercise to kind of calculate what you need to monitor precisely. So if you would like, we can send you one of those. But no test, no quiz.
I guess we did a really good job.
I guess we did. Well, thank you so much, Gil. I really appreciate your time, and all that information is very helpful. Like I said, I can, wait, are there people that come out and do the setup for us? Setup, I'm assuming as far as the probes?
I think the thresholds, I think there might be asking about the thresholds. Maybe.
Well, if they are talking about the thresholds, Gil, is that something that sentek can set up for them, or maybe their dealer?
Well, like I said, the slides actually are pretty self-explanatory. The customer should be able to run through those quick numbers. We can take a look. I can help them look at the numbers if the customer wants, but the slides, I can actually tell you what slide number it was. It was on slide 14, right? So.
All right. It's an anonymous attendee, but I can, if you want to send me your email, whoever asked about the threshold setup, I can email you that slide that Gil's referring to on how to set those up.
Yeah, let's add some science here if anybody wants to really dig in deeper. There's a lot of new research in regards to stomata regulation, and they're really starting to understand plants that are, the keywords are isohydric and anisohydric, meaning that isohydric plants respond readily to water stress. Their turgor on the stomata guard cells are very fast. And anisohydric plants want to capture the most amount of carbon as possible. They'll keep their stomata open even when they're almost dying, right? So there's those two basic levels of stomata regulation. And then just so everybody understands, 95% of all water used by plants is for thermal regulation. If I'm not mistaken, photosynthesis stops around 94 or 93. I can't remember the exact number, but it's to keep the leaves cool so that the plants can continue to uptake carbon and continue to produce carbohydrates.
Okay, interesting. I got some feedback about the threshold setup. So they are talking about the thresholds, and they currently are growing row crops and are super busy, and maybe just need some assistance setting those thresholds. So is there maybe a consultant they could talk to? Okay.
Yeah, definitely. Like you said, you could either send my contact, and I'm also sending you the slides so everybody can have access to those slides.
Sure, perfect.
It's all free, right? You're not paying for the USDA is a great source of information. So the soil water characteristics, the NRCS soils layer that goes into Google Earth, and the FAO's website. With those three tools, right, you can do all the quick examples that we ran through here. And they're all free.
That is a good word. We love that. All right. Well, I shot them your information, and then I can also email them afterwards as well with the slide that you're referring to, Gil. But if there's not any more questions, like I said, this will be recorded and posted, and you guys will all get an email notifying you of where to find that video for reference.
We have a holiday coming up, right?
Holiday on Monday.
Beautiful.
All right. Well, on that, I hope everyone enjoys their 3-day weekend. Have a great Memorial Day. Thank you, Gil, very much for joining us. And contact us if you have any questions.
Thank you, everybody. Have a great Memorial Day. Bye.